Well, good afternoon slash morning slash lunchtime, everybody. My name is Aaron Standard, and I'm here with Gregorius Sodharmo, and we are going to run our November Akka.net Community Stand-Up. Gregorius, how are you doing today?
Oh, pretty good. And how are you?
Oh, doing all right. Got my first pull request trying to promote some generative AI garbage on the Akka.net central repo a couple seconds ago. So that was interesting and different. But yeah, I'm ready to go ahead and talk a bit about some of the work that we've been up to. And I kind of left our section on future developments in Akka.net a little open-ended, but I do want to speak to that a little bit, even though it's not explicitly on the agenda. So first things first, why don't we
Mhm.
talk about this community contribution, the Akka.Persistence.EventStore
Yes.
1.530? All right, lay it on me,
Um,
Gregorius.
a contributor, Matthias Jacobson, added a support for system.text.json and writer UUID for EventStore, which is pretty cool. So we did a release on that. And yeah, that's about it.
Yeah, well, the system.text.json stuff is gradually making its way into more open source projects. I saw stripe.net is in the process of trying to migrate from newtonsoft.json to system.text.json. The
Mhm.
biggest advantage of doing this, in my opinion, other than performance, is that you can get the compile time sort of support for system.text.json. I just started using that myself in one of our projects. I was hoping to have that project announced as the show and tell for this community stand up, but unfortunately, the legacy project that I've been complaining about on Twitter for the past week and a half kind of sucked all the air out of the room for that one. So we might have to wait until December or January for that particular announcement to make its way out.
Yeah.
But such is life. But anyway, I've had a chance to play around a little bit with
Mhm.
STJ's sort of compiled time experience, and I'm a big fan of it so far. I think that it basically is both a more performant and b more secure than doing sort of like reflection based deserialization. So I'm
Mhm.
definitely interested in doing that, but it does require more planning to be able to use it correctly. Can't note polymorphism and compile time support for serialization do not play nicely together. So that's that.
Yeah. It is
um
kind of cool though. It acts more like protobuf instead of JSON because it's precompiled.
Yeah, absolutely. Well, the thing that you kind of have to have in order to make this work is something that Akka.NET serialization system already supports, which is you need to have some way of previewing when you're getting data over the wire. You need to have some way of previewing what the destination data type is supposed to be, and you map that sort of like this would be like the string manifest in Akka.NET, right, Gregorius?
Hmm. Yep,
String to
exactly.
manifest plus the serializer ID, those two bits of information. And you need to be able to find a way to map that back into an actual, C sharp or F sharp object of some type. And we already support that. What platforms like NewtonSoft.json did is they would go and encode that into a little data field and use during the process of doing its reflection, it would kind of like pull that out of there. You would need to do
Hmm.
something that's a little bit more robust than just keeping a full type name in there in order for this to work. So that's kind of one one thing worth considering. And I'm going to talk a bit more about serialization when we get to our future plans as well. Next,
Hmm.
you and I both have some pretty big changes that went into Akka.net 1.531, which just shipped yesterday.
Hmm.
Um, let's
Lots of
see
bug
here.
fixes.
Oh, I'm trying to think. What should we go take a look at first? Well, you know what? I'm going to segue at the end here into talking about Akka.Hosting and Akka.Management because that's also because this bug fix and those ones are all related to each other.
Hmm.
So why don't I start by talking about a couple of the 10-year-old bugs, and then you can talk a bit about the ones that relate to Akka.Management. That sound good?
Sure. Yeah.
All right. Okay, so we fixed. So I mentioned on Twitter that we've been finding a whole bunch of decade-old bugs and fixing them. There was that infamous one back in July that we fixed around the duplicate shards issue. Well, we had a user in our premium support channel on Discord. This is for Petabridge support customers. Report this issue to me, which was basically an issue where, in fact, I'll go to the original issue report here, where basically, and this also affected the way they discovered this was via cluster sharding, where essentially an address is not necessarily unique inside Akka.Cluster. If you have a stateful set in Kubernetes and one of those pods really quickly like restarts or gets redeployed as part of a software deployment, it's possible you can have one instance of that node leaving the cluster and another instance joining the cluster at the same time. Well, we have a construct inside Akka.Cluster to deal with that called a unique address, where we basically append a sort of randomly generated long integer to the back of the address. And that's how we can detect that nodes have restarted. It's kind of like a way of detecting, similarly to how we can detect if an actor has been killed and recreated with the same name. We want to like distinguish that from an actor rebooting. We do the same thing if a node with an address is in the process of leaving and another node with that same address joins the cluster. We assume, aha, this node must have restarted, and we try to down the old node that's leaving. Well, this resulted in a irreconcilable bug in Akka.Cluster where none of the nodes were able to successfully transition the leaving node to down as a result of another node in the cluster also being downed at the same time. And the long and the short of it, in terms of why this bug was so kind of pernicious, it's a fairly simple change, but basically the problem was, how do I put this? The problem that we ran into is these illegal state transition errors, and these would get thrown over and over and over again, and it would basically force you to do a full, to completely tear down the entire cluster and redeploy it. That was the only fix for this. It was basically a really stupid fix, is what the problem was, which is we did all of the correct filtering up here was sort of where we did this. But then on inside the inner loop, we basically evaluated the original data structure without filtering it again. And that's where we could run into this illegal state. So the way I fixed it was basically just by moving a conditional check from the outside of the loop to the inside of the loop. And it's not, has no real performance impact since this only runs when nodes are joining or leaving the cluster, which is a relatively infrequent event. But that solved the problem here. And this should fix a whole bunch of different categorical problems of the stuff built on top of Akka.Cluster. So that was one nasty fix. And then Gregorius, I may have found this bug. You're the one who fixed it. So I'll have you take credit for that. The bug that I ran into here, and this is actually with the new software as a service application that we're trying to get out the door. The bug that we ran into was I noticed messages going missing inside one of my persistent actors during testing, where basically I was trying to go ahead and send a command for pausing and resuming a long running background process is what we were doing. And I noticed that one of my pause commands was going, flying ghost ship or Flying Dutchman on me every single time I was running this test. And lo and behold, and I even had a little link pad example to reproduce it. Well, Gregorius very quickly found the issue, which is this distinct function right here. If you have two messages that you process as an actor, so in my case, I'm sending literally the exact same reference object twice. I'm doing a tell with the same command 2 times in a row in my unit test. Well, that would result in this distinct operation filtering out one of those messages during processing, and that's going to be a bit of a problem for us. And by the way, it wouldn't even matter if I sent that message twice in a row, or if I sent that message once, had 100 messages in the middle, then sent it again. It would still get filtered out via this code. And this was a 10-year-old bug, and I believe it was a protection we put in place to basically make sure that stashing was idempotent. But we have a better solution for that that's been in place for quite a while already. You don't want someone to stash the same message twice. We actually raise a runtime exception when that happens. Gregorius is working on writing an Akka analyzer to make that a compile time exception as well. But as we're discovering, that's probably not compatible with the range of Roslyn analyzers, Roslyn versions that we need to support. So that we might not be able to ship that after all. But that's basically this fix here. So we've had people report like kind of weird bugs about messages going missing and stuff over the years. And like I've always known the Akka.net mailbox is pretty sturdy. And if the mailbox could lose messages, then all hell would break loose. But this apparently has been probably what's been triggering some of that behavior for so many years, is this distinct function here. So that's been fixed and should no longer produce an issue. We did include in our release notes an upgrade advisory for that. Like, hey, this is kind of, in theory, it could be a breaking behavioral change, but we never in our worldview, and you can correct me if I'm wrong, Gregorius, fixing like a critical bug, we don't really count as a breaking behavioral change. Our kind of view of that was, well, the behavior before was broken, and we're just fixing it, So
Yep.
that's kind of our view of that stuff. And then the rest of the, we go back to the rest of the release notes here. The rest of the release notes. So Gregorius, why don't you talk a bit about this one, the cluster singleton logging, and then talk a bit about this cluster sharding issue that we've been working on. So yeah, let's talk about this one.
Well, we have some customers who ask for this feature. It's actually a feature that you can opt out of. Is that when they try to deploy a cluster singleton inside their development environment, they couldn't track if they've done the proper configuration. Like singletons might be missing because they forgot to assign a role to a cluster node or something like that. So we added this feature where the proxy would actually nag you if it couldn't connect to a singleton. Like I couldn't like in default value every 30 seconds it would emit a warning that it couldn't find a singleton. You can actually opt out of this feature by changing the flag in the configuration file if you don't want this, or if you're deploying this into the production environment.
Yeah, I think it's a good idea to have this on, and it's going to continuously log exceptions, which is the right behavior in our opinion. And the reason is like, look, dude, if your singleton proxy can't find a singleton to talk to, it's way better that you get like a recurring warning about that rather than trying to file a GitHub issue here and ask, hey, why am I getting all these dead letters?
Yes.
So we're trying to basically just make debuggability a little bit better here. So this was kind of like a developer experience improvement. Is what this was about.
Yep.
And then this last issue, Gregorius, and we'll use this as a segue into talking a bit about Akka.Management and Akka.Hosting. You've been doing a lot of work with Akka coordination lately and its integration with sharding.
Yeah, well, this is a really weird bug. I think the original code assumes that when you release a lease from inside an actor, it will be a quick, like, operation, basically, like talking to a Kubernetes API endpoint would take like milliseconds. In this case, we found a problem when we use an Azure lease that could take like a few hundred milliseconds. And the way we release the lease on the old code is that we just use a detached task and that's it. Now, there's a possibility that the actor system itself shuts down faster than the lease code execute, so the lease wouldn't actually be released. So when the actor system was brought back up, it spun back up, it will start a really nasty lease contention problem because the old release was not released properly. So we actually block the operation now, uh, making sure that the operation completes either successfully or failed, and then shuts down the actor.
So if you're not familiar with Akka coordination, it's basically a distributed locking system. And the primary place where people have been using it has mostly been the split brain resolvers in Akka.cluster. And the idea behind it is that if you feel like the consensus within Akka.cluster isn't robust enough to make good decisions, then you can use this coordination layer as like another set of checks on top of that. The problem that one of our customers ran into in a live environment was that when they were rebalancing shards, the old shards weren't releasing the lease before they terminated. And as a result of that, you'd end up with a whole bunch of shards that couldn't allocate on the new node. And you just see error spam all day long. And like Gregorius mentioned, the fix for this is to force that what was previously a detached task is now a synchronous blocking task. Have the shards force the lease to get released before they transition. So
Mhm.
that was one part of the fix. And the other part of the fix you did, I'm going to jump down to Akka.Management here. The other fix you did was actually correcting some timeouts inside the Kubernetes and the Azure lease implementations themselves,
Mhm.
such as, yeah, moving the lease actor to the system hierarchy. Go ahead and explain why this is important.
Well, moving the actor from the user space to the system space is important because if you run it inside the user space, there's a chance that the least actor would be killed before uh, the actor itself finished processing all of the leases. By moving it into system, we make sure that it will be killed last, basically. It really depends on how the shutdown was done, and sometimes there it's not really deterministic who's getting killed first. So by moving it to system, we make sure that the least actor would be shut down after the actor that's using the lease itself is being killed.
Yeah.
And
So, oh, sorry, go ahead.
yeah, the rest of the changes is mostly for easier debugging. Uh, now in the debug log, you would see who the owner of the lease that is being released, or who the owner of the lease that is being created is, and the name of the lease, and et cetera, et cetera.
So more and more users are starting to use Akka.Management and Akka.Hosting and some of the other like higher level libraries built on top of Akka.net. And as a result, we're
Hmm.
finding more bugs and we're fixing them and everything is
Hmm.
maturing apace, which is fantastic. So that's
Yeah.
really kind of what was going on with this. And then with Akka.Hosting, we basically just bumped the Akka version, although with some of the stuff that you're working on currently, Gregorius, we're probably going to be fixing some Akka.Cluster and some cluster singleton fixes
Hmm.
we're going to be introducing some bug fixes for that
Yeah.
probably in another small release in the next, I don't know, week or so here. Um, so Vagif, the guy who submitted this, if you're watching, we have not forgotten about you. We're working on this. um, so that's all underway right now. A couple of other things we did. We did our webinar on testing Akka.net applications. So we had about 150, 200 people register for that. So thank you. We have released the first half of that on YouTube. So it's available on the Petabridge YouTube channel here. So you can go and check that out if you want. Part two will probably be released on Thursday or Friday. So we'll get a chance to see that come out soon as well. I haven't been as active on the YouTube channel lately since I've been pretty busy working on trying to get some applications shipped before the end of the year. But I'm hoping to pick that up again soon. So speaking of our future Akka.net plans, I'll go ahead and stop sharing my screen here since I don't have anything on the agenda. So one of the projects that I've been working on is directly relates to like .NET open source tooling, but it's more of a SaaS service rather than a library or a component. I've been working on that, and I've been using Akka.net quite heavily to power all of it. The system relies real heavily on the sharded daemon sets and cluster sharding, cluster singletons, Akka streams, stream references, all that good stuff, and Akka.Persistence quite heavily as well. And I've been thinking a lot about Akka.net 1.6. Akka.net 1.6, as we've been talking about for the past year, is going to be very focused on performance, is the big thing. Akka.net 1.5 was focused on developer experience. 1.6 is going to be a performance-oriented release. And there's a couple of big areas that we want to work on there. And I want to talk about it related to this SaaS project I've been working on. Um, One big area that we've talked quite a bit about is rewriting Akka.Remote to basically be built on top of a multiplex transport. That's more than likely going to be quick. QUIC, that's what HTTP3 is built on top of. I've kind of talked a bit about that. We've also talked about adding AOT support to Akka.net. That's something that we're intending to do as well. I've already got some ideas for how we can start gradually introducing that. But the big linchpin that's going to hold everything together in terms of making Akka.Remote, Akka.Persistence faster, and supporting AOT is a reimagining of our serialization layer. Gregorius did a proof of concept well over a year ago of using source generators to generate basically protobuf sort of files and everything from Akka.net serialization objects. And this is one of those cases where I'm glad we've been waiting to kind of get this thing designed and built, because the tooling choices that are emerging in the .NET space are getting better and better and better for being able to support basically compile time serialization options. One of the things that I learned from this project is, and Gregorius, you've been working on this project too, how many total message types do you think we've had to write serializers for? Maybe like 70 to 80 at this point?
Yeah, quite a lot.
Quite a lot. Partly it's because we're doing this like domain-driven development thing, and each domain has its own set of message types and state types that need to be serialized. And we're not over-engineering it. We're just kind of doing a good job of like modularizing things. But going by the number of times I've been tripped up by a serializer definition missing and having to go back and do it, particularly at a fairly early stage in development here, is really annoying. And the reason why we've had to write serializers like this early on in the project is because we're working with a lot of data structures that are good for Akka.net, but are not good for polymorphic serialization, namely system.collections.immutable is a really good example of one of those. And anyway, this has been making me think quite a bit about our serialization system and how that's going to evolve and develop. And what I'm largely considering at this point is a range of options from what we had previously considered doing using source generators. I think it's safe to say, Gregorius, by the way, that source generators as an option is probably a non-starter. I think the reason being is that there's no way to get them to cohere together. They're all going to run independently from each other and do their own thing. And getting it to do stuff like check for version tolerance between, let's say, releases is probably a non-starter. So I'm thinking more than likely what we're going to end up doing is probably writing a custom .NET tool that's going to do some code synthesis at the beginning. It'll probably still use Roslyn and all that to do it, but I think it needs a little bit of organization to be done. The other possibility that I'm very excited about, let me look for, let's see, type shape for C#. I should have probably brought this up in a browser earlier. Here we go. The other thing I'm very excited about is, I guess I have to open another browser tab for this since I'm in anonymous mode here. The other thing I'm very excited about is, let me pull this up here. I guess Eric just renamed this the other day. Well, I thought it was type shape for C#, but basically they're calling it polytype, which is the ability to go ahead and generate things like CBOR serialization for an arbitrary data type.
You might want to
share I'm not sharing my screen anymore. Right. Thank you. Thanks for letting me know. All right. Let me grab, appreciate that. Let me grab that here. Here we go. This is polytype, which is, this comes from, Eric Drasopoulos, who's on the F# and also like .NET runtime teams. And the one thing that's super ugly about like some of the new conventions for doing code generation is having to declare all of your classes as partial. And that's so it can generate methods in separate code files that are owned by the source generator is what that's for. But what's kind of slick about this is the ability to code gen JSON or CBOR serialization out of the box. And we can do things like, if we're trying to, let's say, design an Akka.net serializer construct on top of this, we could look for all the types that are decorated with, let's say we decided to use this. We could look for all the types that are decorated with generate shape and organize them by assembly into a serializer class that has its own unique manifest system and its own unique serializer ID, and just kind of automate that whole process for everyone. that's something I'm super keen on doing, because my own experience working with our serialization system has been frustrating with Akka.net. So it's good that I'm spending some time, and Gregorius is spending time too, dog fooding Akka.net and like a real application that we're trying to use to like make money down the road, because it's forcing us to kind of discover another set of paper cuts that haven't been addressed very well. Um, like Akka.Hosting was a huge sea change that made configuration a lot better for us. In this legacy application that I've been complaining about on Twitter, I went through and deleted all the Hocon files last week because we don't need them anymore, and replaced a whole bunch of like homegrown um, code that existed, basically in Akka.net 1.4, replaced all of that with Akka.Hosting, deleted a bunch of like infrastructure library code that didn't need to be there anymore. That all feels great. I'm thinking the next big area where I really want to apply some time to that is going to be serialization, and I think serialization is probably going to be where we are going to start our work on Akka.net 1.6, because it seems obvious to me that this is a nexus of both frustration for developers from a developer experience standpoint. It's also a major performance hazard, even without replacing the Akka.net remote transport. This is something that needs to get addressed. And then on top of that, I also think that it's a bit of a the polymorphic serialization stuff is a bug pit. It just always has been. So we can basically hit three birds with one stone, I think, if we do this well. I think we can do this in a way that's backwards compatible. We got to think about that in particular with Akka.Persistence, because people have data at rest in some of those snapshots and in those journals that could be, the age of that stuff could be, traced back to 2015. It's pretty old data potentially. So we
Mhm.
have to be able to continue to support that. I think the manifest and serializer ID system in Akka.net should allow us to do that quite well. But this is something that I'm very excited for us to kind of start thinking about. I think in terms of time frame, the real engineering work on Akka.net 1.6 will probably start at the beginning of Q2 next year. We've got a lot of product stuff we need to get out the door, and if you want us to get to work faster and sooner on Akka.net features, have your organization buy a Phobos license or a support plan. That'll help us do that. But in the short run, we're working on getting a couple more, I think, products out to market that should really help existing Akka.net and also just generally .NET open source users. I'm looking forward to getting a chance to give a presentation on some of that down the road. But in the meantime, thank you very much for your time today, everyone. We really appreciate it. And we will look forward to seeing you all in December for our final show and tell of 2024. So take care, everybody, and we'll catch you next time.